Capstone Capital Projects is excited to present the SR-125 interchange and Main Street alignments. This is a continuation of the original 50% design, and this is our team. Some of the main design components for the project include the road alignments and bridge structure. For the bridge structure, this includes the box girders, the vertical supports, and the foundations.
As for the geotechnical report, CCP retrieved an investigation performed by Geocon on a site 3,000 feet away from the proposed bridge. This investigation covered various tests as shown below, as well as boring logs. We found that the site is underlain by compact fill overlying O-type foundation. The compact fill is considered to be Cal-OSHA type B soil, and the O-type foundation is revealed to be Cal-OSHA type A for excavation purposes when cut and fill grading. Groundwater was not present during any of the borings during the investigation, and based on Caltrans fault maps, this site lies along the Rose Canyon fault zone.
For our stormwater design, the area of the proposed site falls under a minimal flood hazard according to FEMA. And due to the nature of this, we used the 6-hour 100-year storm intensity in order to find the calculations. Additionally, the longest project span was used to determine the flow rate. Flow rate was calculated using the Q equals CIA formula, where Q equals flow rate, C equals runoff coefficient, I equals intensity, and A equals area. The calculated flow rate for this area was 7.25 cubic feet per second. As a result, CCP decided to extend the stormwater main 900 feet east using 24-inch reinforced concrete pipe. The installation of a type A storm drain cleanout is necessary in order to extend the main.
Regarding the structural design, initially the bridge design was done based upon 20 feet clearance, but we changed that to 70 feet, and we did a new bridge design based upon a new bridge clearance. We changed the clearance of to 70 feet because the Rock Mountain Road and the Millennium Avenue has above sea elevation of 560 feet, and we needed the bridge to have a slightly lower elevation than 560 so that the water caught within the new project will travel along the new street alignment towards the bridge and then drain into the SR-125 freeway below the bridge. The length of the bridge is 390 feet, and the width of the bridge is 100 feet. The bridge contains of two 15-feet car lanes in each direction. It also includes two 5.5 feet bike lanes and two 5.5 feet walkways in each direction. Our design contains 15 feet median and 1.5 foot outer barriers.
Expanding on what Mohammed just said, the bridge had to have a complete redesign of the box girder section. The original size was at 3 feet, and then the section depth was increased to 96 feet. The box girders have a width of 5 feet, so 20 of them are required side by side for the entire bridge structure. And a vertical support section, vertical support was designed to be 8 feet long by 100 feet wide, spanning the entire width of the bridge, and it would be the 17-foot depth in order to match the vertical clearance. Additionally, piles were designed specifically for the project. These piles were made circular, having a 6-foot radius and a 50-foot depth. There is 12 of them for each vertical support. And since there are 3 vertical supports, 36 of them were used for this project. For transportation design, the project used lane striping from the Caltrans standard drawings. We use striping detail 22 for no passing in 2 directions, striping detail 25 for ledge edge lines, and CCP also calculated that the area is experiencing a level of service C under current conditions, but based on the improvements made for the project, the proposed streets will improve to a level of service B. Some other striping that we used were the striping detail for chevron markers, which are going to be included in the on and off ramps. Additionally, the type A curb ramps based on county drawings are going to be used on all 4 points of intersection for the intersections.
The setup is simple with a road extending from Rock Mountain Road, crossing a bridge, and turning left to match up with Millennia Avenue. I drew up the on-ramps and off-ramps to match up to the road on either side of the bridge. Next slide. The road assembly was put together using instructions from the highway design class and a set of conservative estimations based on the existing soil report. Using the instructions, I calculated the depth of the asphalt, the base, and the stud base, and using the lane widths given, I constructed the assembly and applied it to the roads.
All right, so moving on to the construction phasing part of the project. So currently there are 4 main phases for constructing this intersection. So the first is site work, which consists of cutting and filling the terrain in order to make space for the roads. Road paving is second, which consists of subgrade and asphalt installation for all new streets, on-ramps, and off-ramps. Third is piers and abutments. This phase, along with the fourth, will be critical due to traffic closures needed to perform the work on the bridge. The last phase is girders, bridge deck, and roadway, which rounds out the construction for this project. Next slide, please. All right, now on to the engineer's estimate. So as you can see, this is our cost breakdown for the project. The total project cost we calculated is about $37.8 million, but with a labor factor of 60% applied to account for additional labor costs, we come to a grand total of $60.5 million. Our pricing primarily comes from the City of San Diego's bid items, pricing trends based on similar products, and vendors for roadway materials such as concrete and steel. Thank you guys for watching.